Hey there, School of Tomorrow students. What we're going to talk about in this video is kind of a zoomed out view of how to fit some puzzle pieces together, but for continuity, I do have some Spider and some Codesters. If you've been watching recent videos, I just went through a whole series where we were looking at how to use the non-local and global keywords in the Python language. And this code on the left, I'll run it a little bit later, but as you can see, I'm playing off that same theme by embedding two functions inside another function and then using non-local to connect what's going on, kind of like glue, and then I actually call these functions. I call one of the functions and return the other in this section. We'll get back to this in a minute. The zoomed out thing I wanted to talk about though is, so you're learning all this Python for what reason? I mean, it's fine to have cute little slideshows. I'll run this. This is Codesters for those of you unfamiliar. I'm showing in some of my examples that you can repurpose it to serve as like a slideshow viewer. In this case, the slides time out after about 15 seconds, maybe to remind the speaker or presenter that they don't have all the time in the world to get through this. 15 seconds is actually a long time. So cryptography is going to be a theme here. What I'm going to do is pull up what I call a roadmap of how I propose some schools might want to go in terms of their design and in terms of how they approach what we call STEM in North America. Not a totally accepted concept everywhere. Science, technology, engineering, and mathematics. And if you've been with this channel a while, you know I talk in terms of STEM versus path. Philosophy, anthropology, theater, and history. That's how I define path. And under history, well, under theater, I have like politics, which is also creating history. Big tsunami happening here on the screen, it looks like, but what's going on in most of this particular video, and I'm referring you to Rebooting K through 16, one of my 3 years ago videos. I'll just see if I can jump into the picture I want. It mostly just scans over a diagram where I'm showing you coming up on a track. I use the track metaphor. That was pre-college. That's me yakking. And this bottom track, let's make this bigger, is, probably don't have to do this because I do a lot of size adjustment later when I do post-editing. We come up to the algebra train station and there's a branch point here. On the right, you go with what's considered conventional today. High school calculus, trigonometry, and like that. What we call pre-college math didn't used to include calculus. That was, and why doesn't it have more number theory? And couldn't it have this or that? And blah blah. So there's always people, no matter what your inside track is, there are always outsiders wanting it to be different, right? And so if you're defending this track, you always feel like you're being criticized because it, but you know that there's only so much time in a day and blah blah. So my proposal has always been, not always, but for a while, that we really pioneer a second track. And what's in reality happening is this is what everyone's calling computer science, and they're actually hiring a different faculty, and there's all kind of politics and so on, learning to code and so on. I'm more considering both of these tracks to be STEM, math, could be taught by the same people, and the course is taken by the same people. You're not asked to choose, like I'm only going to go on one track. It's not like that. It's just in this future, we'll brand lambda calculus versus delta calculus. Now, in practice, lambda calculus is more of it's, the letter lambda has taken on a life of its own, for one thing. And no one's actually currently using lambda calculus to include all these digital math topics like RSA, which in this case stands for cryptographic algorithm. And building up to that and getting used to cryptography, you can get into group theory and all this kind of oh, I'd call it finite algebras, things that aren't calculus a lot, but still important, still part of the culture, and more so than people were maybe anticipating or expecting when this older calculus, delta calculus, let's understand Newton. We still want to understand all that physics. And at the top of this, I show in grades 13 through 16 how we could connect to the sciences higher up, more deeper into it and stuff, right? So we can go right into science from the lambda calculus track. You study computers, Jupyter notebooks, all kinds of scientific techniques. You might pick up your calculus in the college level, postpone it, not take it in high school. So 9 through 12 refers to grades 9 through 12. So Python's very strong with cryptography, which I'm putting there under the lambda calculus side of things. Other languages likewise. So the point is, the reason we're learning Python and why you might be learning Python and or JavaScript and or Java and or many other languages where it's Pharaoh like up to now, like here we are in 2019, so maybe in the far future, like 2020, their languages I can't even imagine. But in this moment of history, I'm finding Python good for that. And I've got at my website for the last 20 years or so all this stuff on cryptography. Now, it's buried deeply in this website, and whether anyone finds it or not, it shows that I was doing my homework at the time and accounts for why, even in my current lessons, I'm able to, talk about group theory and stuff because I did some work on that in Python. So my approach to learning, you learn Python as a means to an end. Once you have the idea of the grammar of Python, you leverage that to understand topics in math that long predate any computer languages, really, such as cryptography. And I'll end now by talking about, so that's the zoomed out view, right? This track system where we allow ourselves to pioneer the lambda calc side of the curriculum more and open that up more. And if you want to call it computer science, I'm not here to say you have to. It's more like if I were designing schools, we might think in slightly different terms. So I'm coming across as someone who designs schools just so that I can talk in that way. Codebreaker, story of Alan Turing. Watched it yesterday. I'd seen it before, but not for a long time. Maybe I saw it on YouTube. And I've seen the Imagination Game, or Imitation Game, I'm sorry. The more fictionalized version of the story. I found this one as a docudrama with an actor playing Turing and his psychotherapist. Even though it was kind of stereotypical, the reason we have stereotypes, as Glenn's pointed out, is they come from some truths, right? There's some reviews in some way. Yes, we do have tall bikes in Portland. Speaking of stereotypes, this guy was going by pretty fast, so I kind of missed. Well, that's pretty sharp once you zoom in. All right, so that's what I wanted to say is that in the zoomed out view, we do a lot with cryptography, and that's the next destination for, as you learn your Python, start picking up on cryptography, which includes things like hashing, right? And the thing is, with all the new cryptocurrency talk and Ethereum and all this kind of stuff, I'm more fluent, I understand better. I'm not a super expert on, but I can follow all these things that I'm reading and watching better because of my little workouts in the Python world, right, with group theory and stuff like that. So I'm suggesting, hey, this works for me. You might want to try something similar, right? But then don't forget to go into the lore. In other words, it's not all about super technical stuff like algorithms. It's about who did what when, who is Richard Stallman, who is, how did the open source movement affect any of this? How does design science revolution, as Fuller spoke about it, connect with the free and open source revolution, as some call it, that actually did happen? I think people who read Grunship Giants and things about Fuller's scenario is like, well, that would have been nice if we could have had a design science revolution, and 10 years that would have saved us from oblivion. But hey, feels like oblivion. But the thing is, nothing ever happens exactly as you envision it. So, in fact, that would be impossible, really. So, of course, the design science revolution, what did happen was an open source revolution, you could call it, which isn't over yet. And we're still recruiting, and we're still hoping, people who are in engineering, if you're in a destructive kind of engineering, like what we would call a military, you're trained to destroy, you still have a lot of engineering and skills there, and logistics abilities, and creation abilities, like you're building a military base. So there are things that apply across the board, right? Cryptography is another one of those. In other words, people are going to use cryptography across engineering flavors. So your Python is going to be useful to you, and your other computer languages, even if you're transitioning from being like a quote destructive engineer to a more constructive role, right? Because we don't need to be going around destroying infrastructure. We're kind of realizing that, sort of waking up. It's like, wait, we're working really hard and then we go and destroy our own stuff, right? That made sense maybe when it was less of a small world. All right, and the last thing is go back to Spider and explain this and run it, okay? So what may be a little exotic for some of you is the itertools star map tool function, that I can use that to map something and have it apply, and I'm going to map randint. And the thing about randint is it takes two arguments, right? So if I go from random import randint over here, let's take a look at it. You need these pseudo-random numbers, right? So I want a random number from between 1 and 10. See, it takes A and B, and neither of those are optional, and it is inclusive of 10. So that's the randint. Now, how would I map that? If I go map like this, map randint, and I try to map that, how can I map that? Can I map that to pairs? 1 through 10 once, 1 through 10 twice. In other words, these would be the argument pairs that I'm trying to map to. That doesn't really work. Actually, of course, that doesn't work. Let's try it. At least syntactically correct. Well, that did work, actually. What did I get out of that? Okay, so it turns out this actually does work. No, it doesn't. I got back something that doesn't work. One positional argument B. So if I use star map, I can do this. I can say from itertools import star map. Star, think of as the little star you put in front of arguments when you pass them into functions and you want to split them apart, right? That kind of star map. So if I just change this to star map and get a list, I actually do get two different random numbers every time, right? Because I'm exploding these tuples into the A and B that are required, and that wasn't really working before. So that's what's going on here, and in setup I'm creating three random numbers in a kind of a syntactically crazy way, but it works, and I wanted to illustrate those concepts. And so ABC, being non-local, now become available in the container function outside of setup. If this thing gets run, which it does, it gets run even as container is being run. So container gets defined first, and then when we actually call container, which I do down here on line 33, I actually don't call container, I call what container returns at that point. So on line 30, I should say, that's where I call container, obviously. But what do I get back? I get back the second function, payload. Not run yet, just ready to go. And because it also has non-local ABC, setup and non-local end up talking about the same thing. They're in the same namespace, the same local executable space. So when I run this thing, ABC start out as none, 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 but then setup runs and kablam, I've got 3 random numbers for A, B, and C. I return payload, so far it's just a function, but it is already ready and bound to the same ABC just outside the door, so when it actually does return a tuple, there is something to return. I get back the 3 random numbers. Every time I run this, of course, it's different 3 random numbers. So again, the focus here is more or less on scope rules. What's visible to what? Like, there's no global ABC anywhere, so I can't now ask to see A, because there's no A defined. It all stayed in Vegas, you could say. All right, talk to you soon. I hope that gives you more of an overview of where I want us to focus. Take your Python skills and build your abilities around, say, cryptography and other sides of math that aren't necessarily the usual calculus and so on that you're getting currently in 2019. There's a kind of a fixed curriculum right now around where I am that isn't too sure how to go forward by integrating these topics, and I'm kind of giving you some suggestions. All right, talk to you soon.